Hello and welcome back. Now that you have trained a classical machine learning model, we'll see in this lesson how to train an artificial neural network. Before we start training an artificial neural network, let's look into some of the basic concepts of artificial neural network and how they work. In classical machine learning models, we looked at this equation where y is the target value that you want to predict given x1 and x2. And we said we could use an equation that looks like this, which is w1x1 plus w2x2. But this assumes that the relationship between x1 and x2 and y is linear. But what if the relationship is not linear? In that case, what we could do is we could have a nonlinear function over here, which is sigma, put on top of the linear function, and this would give us a nonlinear function out of it, and where we could put in our values x1, x2 through xm into it, and it would help us predict y. And this nonlinear function is called the activation function in artificial neural networks. Some of the examples of this activation function are sigmoid function, and this is the equation over here, and in all of these, z is the output from the linear part of the equation that we're trying to solve, and then we impose this non-linearity into it. And we could have a tan hyperbolic value function. A value function is one of the most commonly used functions nowadays in artificial neural networks that looks like this, where it's 0 for any value less than 0, and it's equal to the value when the value is greater than 0. There's also another function called wiki-lelu, which looks something like this. And you can find some of these discussions in the paper that's mentioned over here. What do we do with this is we can put all of these neurons, the green things that you saw before, where each of these green boxes, which represents a neuron, has a linear part to it, and on top of which we have a activation function. So the output from that is then served as an input for this, which then uses the linear function and again an activation layer on top of it, and then passes on so on to the next neuron in the next layer. So the arrangement in a neural networks look like this, where you have a series of neuron, a column of neuron is called a layer, and you have multiple layers put in together to form this artificial neural network model. So the input to this model is from the input layer, and the layer which gives the output is called the output layer, while the layers that are in between are called the hidden layers. So we have those W1s and W2s in the linear part of a neuron, and the task would be how to optimize those weights, or W1s and W2s. So what we could do is we could have the input pass through the neural network, and you start with an arbitrary W1s and W2s, and then you have an activation function to it, and it will give us an output. And we can compare the output with the desired output, or the target value that we have, and estimate the error. Once the error is estimated, we can take the derivative and do something called backpropagation. And we'll look into a little bit of math over here and what is happening in this case. So when you calculate the loss, you calculate where h is a hidden layer for us, and you calculate the value, what the predicted value is, subtracted from the expected value, and this is taken the square of it, so you can have mean squared error over here, and that gives you a loss. Once you have the loss, you take the derivative of loss with respect to a particular weight, and that will give you how much you need to change the actual weight. So once you get the derivative, you look at the initial weight, which was wi, and then subtract it from this derivative that you get and multiply it with a learning weight, which is called alpha in this case. So after one iteration, you would get an updated value of w1 based on what the loss is. And let's say the loss is 0, this derivative becomes 0, and this part becomes 0, and the weight is, the updated weight is the same as the previous weight. But if it's not, you change it a little bit so that the error becomes 0 sometime when we iterate this process again and again. So in summary, we have a forward pass through the neural network where it predicts the value, and once the value is predicted, you find the error in the prediction and then propagate it backwards, which is called backpropagation, where you try to optimize the weights, and you have some parameters which decide how much the weight should be optimized. And while we are training the model, we'll see there's something called an optimizer, which does all of this part for you. You need to select what type of optimizer you need the model to use, and based on that, it'll try to do all of this for you. And we have a loss function that will help us compute the loss for training.